Welcome to my YouTube channel Captain Chandan. Today topic is triangle of velocity. And this is important chapter in general air navigation. You will learn how wind affect on aircraft. There are many numericals for CPL and ATPL exam based on this chapter. Kindly subscribe my channel for more update or you can contact me for any kind of suggestion. Thank you. We'll start now.
Triangle of velocities. We'll see some definition before proceeding on topic. Heading. Heading is defined as the direction in which the fore and aft axis of aircraft is pointing. It may be measured from true magnetic or compass north, or simply we can say datum north. We'll see some example. If aircraft is flying to north heading, it will be 000 heading. For east heading is 090 degree. For south heading is 180 degree. Flying west heading will be 270 degree. Track is the direction of the aircraft path over the ground. It may be measured from true or magnetic, or you can do also using compass north. On a chart, an aircraft flying from Spain to Romania, so the path of aircraft described over the chart or earth are called track, and it is measured clockwise from datum north. In this case, track is 045 degree. Drift. Drift is the angular difference between heading and track, or you can say track made good. As you can see, track is 080 degree, heading is 070 degree, so the drift will be 10 degree. If the track is right of heading, then it is a starboard drift, that is right drift. If track is left of heading, then port drift, that is left drift. In this case, drift is 10 degree starboard. We'll see some examples. Suppose one boat is departing from position A to B. Distance is 10 nautical mile. If the water is calm or still water, then with 10 knots speed, boat will reach position B in just 1 hour. Now, if water is following or 6 knot speed of water, then boat will reach at new position, that is C, which is 6 nautical mile from position B, and it will take 1 hour. Boat reaches position C because 6 knot speed of water. But boat have to go at position B, even there is a water speed at 6 knot. So we have to point boat to the new position, that is D. We can calculate the angle, heading and track. This is an example that how aircraft fly if there is a wind. The component of triangle of velocities. First, air vector. The air vector have a two subcomponent, heading and true airspeed, and it is denoted by single arrow. Second, wind vector. Moment of the air masses through which the aircraft is traveling. The air vector have two subcomponent, wind direction and wind speed. So what is wind velocity? The direction from which the wind is blowing and the speed usually in knots. For example, 320/25. So what is the meaning of it? It means wind blowing from 320 direction with 25 knots speed. First letter is 320, that is the direction, and 25, the second one is speed of wind. Similar, wind blowing from 60 degree from 90 degree. Wind vector denoted by triple triangle. Now the third one is ground vector. The air vector and wind vector give the third component, that is ground vector. It describes the direction and speed of aircraft over the ground. It has two subcomponent, track and ground speed. As you can see, on a heading there is a wind coming from left, give a track and ground speed. So drift angle is the angle between heading and track. We study already. The sixth element of triangle of velocity: heading, true airspeed, wind direction, wind speed, track and ground speed. So in DGC exam, the four components are given in the question and we have to find the two other components. I suggest you kindly use flight computer to solve Numerical based on triangle of velocity.
Some flight computer problem solved by Formula 2. We can solve using formula. So first we'll talk a topic about speed, distance and time. So for example, an aircraft flies 210 nautical miles in just 25 minutes. What is the ground speed? As we know that a ground speed is the distance covered in 1 hour. So in 25 minutes, aircraft cover a distance equals 210 nautical mile. So in 1 minute, aircraft cover a distance equal 210 divided by 25. So in 60 minutes, aircraft cover a distance 210 divided by 25 times 60. That will be 504 knots. So the ground speed will be 504 knots. Aircraft travel 504 nautical miles just in 60 minutes, or you can say 1 hour. We'll take second example. At a ground speed of 504 knots, how long will take the aircraft to travel 210 nautical miles? We have to find a time in this question. So 504 nautical mile distance covered in 60 minutes. I will give you some golden rule. Why I put 60 minute time in right side and distance in left side? Because if you read the question, it is asking that you have to find the time. So whatever things, so we have to find a time. So we'll put right side. Like 504 nautical mile distance covered in 60 minutes. So in 1 nautical mile distance covered will be 60 times 504 nautical miles. So in 210 nautical mile, if you solve that one, that will be 25 minutes. We'll see some other example. For a ground speed 504 knots, how far will the aircraft travel in 35 minutes? How far means we have to find a distance. So you have to put a distance in right side and time will be left side. So 60 minutes that will be in left side. 60 minute time take to cover a distance is 504 nautical miles. So in 1 minute distance cover will be 504 nautical mile divided by 60 minutes. So in 35 minutes if you solve that one, it will be 294 nautical miles. Now we'll move some other topic, that is TAS, through airspeed calculation. I highly recommend you kindly use flight computer to solve this kind of numerical. Example, the pressure altitude is 35,000 feet and the corrected outside air temperature is minus 65 degree. The rectified airspeed is 160 knots. So what is true airspeed? By formula, TAS is RAS 1 plus 1.75% times altitude divided 1000. Putting all the value, you will get the answer 258 knots. But if you are using by flight computer, your answer will be 268 knots. Kindly use the closest answer in DGC exam because there is a 4 option. So just look the closest answer. Now calculate the true altitude. For a temperature of minus 40 degrees Celsius and pressure altitude is 25,000 feet. What is the true altitude? True altitude equals pressure altitude plus pressure altitude times temperature deviation percentage per 3 degrees Celsius. Now you will put all the value here. Temperature deviation is actual minus ISA. So actual temperature is minus 40 degree and ISA temperature is 15 degrees. So temperature fall 2 degrees Celsius per 1000 feet. So at 25,000 feet, temperature will be minus 50. So ISA temperature is plus 15 degree at sea level. So ISA temperature as 25,000 feet will be 15 minus 50, that will be minus 35 degrees Celsius. Putting all the value, the deviation, temperature deviation will be minus 5 degrees Celsius. And putting all the value in the true altitude formula, you will get answer. You can solve using flight calculator too. Now calculate density altitude. So density altitude is the altitude in the international standard atmosphere at which the air density would be equal to the actual air density at the place of observation. So in other words, the height when measured in terms of density of air rather than the distance from ground. Density altitude is a pressure altitude adjusted for non-standard temperature. It is not a physical distance. We'll see some diagram in upcoming slide.
So the formula for density altitude is pressure altitude plus 120 times temperature deviation, ISA deviation. Example, pressure altitude is 20,000 feet, temperature is minus 10 degree. What is density altitude? Temperature deviation is actual minus ISA temperature we see earlier. So minus 10, if you put all the value, the temperature deviation is 15 degree. Now density altitude is 20,000 plus 120 times 15, that will be 21,800 feet. We'll look detail about density altitude. So suppose we'll take one cylinder, that is ISA condition, temperature is 15 degree and pressure is 1013.25 hectopascal. So at sea level there is a 4 molecule of density. If you climb, the density will decrease. So at 2000 feet, at 2000 feet there will be 3 molecule only. Now at 4000 feet again decrease, only 2 molecule left. This is the ISA condition. All aircraft performance are calibrated in ISA condition. Now the condition is always not the same. Sometimes the weather is hot, sometimes weather is so cold. We'll take example of temperature plus 30 degree. So if the temperature increase, density decrease. So now the density will decrease at sea level, only 3 density molecule. So the 3, if you look in the first column, it is 2000 feet. So if you are at sea level, your aircraft will feel that he is at 2000 feet density altitude. Now if you climb at 2000 feet in ISA condition, it will feel that aircraft is 4000 feet. So density altitude will be 4000 feet. Even your pressure altitude is 2000 feet. Now if you further climb at 4000 feet pressure altitude, your aircraft will sense that he is flying at 6000 feet density altitude. So remember always, if temperature increase, the density altitude will increase, and density altitude is not a physical distance. Why we need a density altitude? Because of performance, because all the parameter of aircraft calibrated in ISA condition and various factors depend upon density. Now what if the temperature fall with 0 degree temperature, is colder now, colder than ISA condition. So if temperature decrease, density increase. So at sea level there will be more density, more denser. So if you are at sea level, it feels that you are below the sea level. Now if you climb at pressure altitude 2000 feet, so what aircraft will sense? Aircraft will sense that he is at sea level, that is 4 bubble denoted as a sea level. If you further climb at pressure altitude 4000, your aircraft will sense that he is flying at 2000 feet density altitude. So if temperature decrease, density altitude also decrease.